time, and then you leave forever. Are you saying bad words in my mic? You're not the first person that's ever done that. All right.
Who walked in that search today?
Making dumb noises. I don't even know what it is. I'm sure it's very appropriate. All right. Solving the trig expression. We talked about that. 4 basic graphing trig functions. Y equals sine of x, cosine of x, cotangent, right? Let's talk about the weird ones, because you know sine and cosine pretty well. Let's talk about y equals, how about regular tangent? Okay? Let's do that. If you're going to mess around, you're not going to be allowed to be in here, so put that away. Like now, while we're up. Right? So, this stuff. Okay? Tangent we know is the same thing as sine over cosine, right? You should know that from your quotient IDs. If you don't know that, we'll go the other way, okay? Unit circle. Let's draw a triangle. SOHCAHTOA, right? Y is sine, interested in the y coordinate. Because when we have a triangle, this is our x, this is our y, this is our 1. Because it's unit circle, right? SOHCAHTOA, opposite over hypotenuse. Here's our angle, okay? Angle's always in this corner, right? So this is x and that's y. This is the triangle right here. What I've drawn. So this is the angle we're interested in. This angle right here, the sine of this angle is going to be the opposite over the hypotenuse. Sine of theta, whatever this angle is, could be 30, 45, whatever, is going to be y over 1. Also known as y. Sine is just y, because the unit circle says this is 1. If this were 2, it screws everything up, right? It's y over 2 now, it's y over 4, it's y over whatever. But because we're using a unit circle, and the hypotenuse is 1, sine is just really y. What's the cosine of that angle? Cosine of theta equals the adjacent over the hypotenuse. Our adjacent is x. Hypotenuse is 1. Cosine is just x. That's why cosine is interested in the x coordinate. Tangent. What coordinates is it interested in? Tangent of theta. It's equal to opposite over the hypotenuse. Opposite is y. Sorry, opposite over adjacent. Adjacent is x. Y over x. So if I asked you the tangent of 0, that's this guy right here, right? What's our coordinate right here? This dot?
1, 0.
1, 0. So we have y over x. Y over x is 0 over 1. So the tangent of 0 is 0. Do we understand that?
What's the tangent of y?
Great idea. You know what would solve that? How we could find that out? Graphing it. Let's graph it. Okay. So we know tangent is y over x. It's our y coordinate over x coordinate. Do we understand why that is? The y coordinate over the x, the opposite of the adjacent? Yes? Yeah, because sine is y, right? Why is sine y? Because opposite over hypotenuse is just y over 1, which is just y. Cosine is adjacent over hypotenuse, which is just x, right? X over 1. Tangent is supposed to be opposite over adjacent. That's y over x. So it's our y coordinate over our x coordinate. And the reason this is, again, going more into the reason, I guess. Let's draw a triangle over here real quick. This will be very brief. Here's your basic triangle. This is your x value right here. This is your y value. Why is it like that? Well, because, again, this is just a coordinate plane. That's all the unit circle is. If you've got a point right here, how do you tell me what that point is? Well, you ask, well, how far over is it in this direction? Our x, right? Well, it's 1. How far is it up in this direction? Our y, 1. If I draw a triangle, what we're really asking on the unit circle is this point right here. That's why we draw a triangle, right? This point right here, what is it? Well, we find it by knowing our x and our y. Same way you find any point on a graph, right? How far is it over? How far is it up? What's its x? What's its y? It's just a coordinate point. Questions on that? And when I ask about questions, I'm not saying, do you understand it? I'm saying, do you understand what I was talking about here? The words that were coming out of my mouth, did you understand that, or did you kind of go, oh, okay, it's a thing? Option A, I understood exactly what you were talking about, every last word. Option B, I get the idea and I stop listening after a little while. Like, really listening. Option A, don't Option B.
Option A.
In between. Okay. Again. This is the last time I'll do it again, so you can answer honestly without fear of me having to do this every single time. Okay? That's okay. We're interested in this coordinate. That's what this is right here. We're interested in this dot. What are the coordinates of that dot? The way we find that is we ask, how far is it in this direction, and how far is it in this direction, right? You know that this is the coordinate what? This dot right here. 1, 1. Because it's 1 in the x direction and 1 in the y direction. That's the same thing as doing this. 1 in the x direction, 1 in the y direction. This is the same, right? See how that's the same? Saving distance up. This is something that you do. I'm losing my train of thought. This is something that you do when you're doing slope, rise over run. How far is it up? How far is it over? That's all we're asking here. How far is it up? How far is it over? Well, we don't know because it's somewhere up here. We don't have labels, right? So the way we figured out is we asked, well, what's this angle? If that's 30 degrees, we can figure out that this is a half. Because we know that's 1. This is a half. And this is root 2 over 2. Sorry, root 3 over 2. What are our coordinates? Well, the coordinates for this is going to be how far it is this way. Root 3 over 2 is how far it is that way. And how far it is up. A half. The coordinates for this point right here, get rid of the triangle, is that. That's the coordinate for that point. That's why we do triangles, to find the coordinate. Okay. Moving on. Back to what we were trying to do. Graph tangent of x, which we know is equal to what coordinate over what coordinate? The what over the what? Or the y over the x, right? Okay? So, unit circle. We're graphing tangent. We always plug these points when we're graphing tangent. Pi over 2, pi, well, any trig function we plug these in, right? Even if it's a weird trig function. Because I didn't teach you the cheat way, because I know it confused you guys last time when you, yeah, okay. I heard how it went, and it didn't go well, so I decided to skip it instead of trying to force it. It's helpful, but only if you get it. Otherwise, it's a nightmare. Remember when V asked you guys to, like, take all those numbers and do an equation thing and solve for x, and then that will be what you plug in down here?
No.
Multiples of that?
Kind of.
Yeah. I didn't do that because it's helpful if you get it. If you don't get it, it's a nightmare. So just plug in these, it'll be fine.
His name is whatever.
Okay? Yeah, I heard that you could say it. That's really good.
But I am not.
That's really good.
Thank you. I want to live in India someday, so.
That's cool. All right. That's on camera. All right. So here we are. Here we are.
They should date.
Right here. Right here. We're going to plug in these points. Tangent of 0. Well, this is 0. What's our coordinate at 0? 1, 0. Y over x is 0 over 1, so tangent at 0 is 0. Make a table. This helps. We asked, what's tangent of 0 when we plug 0 in for x? Up here. What's it going to be when we plug in 0 for x? Well, we got it was 0, because 0 over 1, okay? Let's plug in pi over 2 now. So what happens when we plug in pi over 2? Pi over 2, tangent of pi over 2 is this guy right here, right? That's pi over 2?
0,
0, 1. Thank you, Emma. Y over x is 1 over 0, undefined. We broke it. When it's undefined, we have to put an asymptote in. We had to do that because otherwise, if we put points there on accident, we've broken math, so we put this in to keep math safe. It is the last wall keeping math safe from the outside world. Okay, pi. We got undefined. Undefined. Does not exist also works, so DNE. Okay. It's not negative, right? That's DNR. Pi. Plug in pi. When we plug in pi for x, we get tangent of pi. Tangent of pi is this guy, right? What's our coordinate? Negative 1, 0, thank you. Which is now 0 over negative 1, the y over the x, which is 0. Let's plug in 2 pi. 2 pi for x means we have tangent of 2 pi. Go around the circle to 2 pi, it's over here. What's our coordinate? Oop, I skipped something. I skipped 3 pi over 2. Go back.
How do you forget 3 pi over 2?
I always forget 3 pi over 2.
That's terrible, dude.
What is the coordinate here?
0, -1.
Thank you.
Why?
For an exchange student. 0, -1 is y over 0. -1 over 0 is undefined, d and e.
D and E.
And last one we got to do is 2 pi. Plug in 2 pi. Tangent of 2 pi is y over x. 0 over 1, which is 0. I do this like every day in class, but it's only funny now because it's on the camera. All right.
Because it's actually
0.
more bloody tired.
Let's plug these in. Pi, we said we got 0, so here's 0. 3 pi over 2, we said we got d and e. Undefined. 2 pi, we said we got 0. Wait a minute. We just have a bunch of points. So, a couple options. Either A, you need to memorize what tangent does. Does it go like this, or does it go like this, right? Okay? Or, and I can show you the way to memorize that.
Do that
Okay?
one more time.
Nope, it's on camera. Watch it at home, okay? So, or you can plug in a point in here. Pi over 4. Let's do that and see what happens. So if you forget which way it goes, plug in a point in between here and see what happens. Pi over 4. Tangent of pi over 4 is here. Right? It divides this in half. Do we see why there's a line there called pi over 4?
Yes.
If this is 90 degrees, this means this is 45 degrees, right? Do we understand why it's 45?
Yes.
All right, so this angle is 45 degrees. That angle is 45 degrees. So when we draw our triangle, we've got a 45, 45, 90 triangle. We know this is 1 because unit circle, any point from the outside of the circle, any point from the center of the circle to the outside of the circle is the radius.
Yes. The one hit.
45, 45, right?